Okay, this is ELO Review 6. Question number 5. Supposed to find y and x given 90-degree angle, 60-degree angle. So we can deduce that that's 30 degrees, making it a 30, 60, 90 triangle, right triangle. It's a hypotenuse of 230. A is the short leg, which is half of the hypotenuse. So if this is 230 root 3, then half of that would be 115 root 3. And I used A as a placeholder to set my ratios. In other words, this is A, this is twice the amount of A or whatever that length is, and then this is whatever A is times root 3. So once I've established that this part is 115 root 3, to go from here to here, I have to multiply that by root 3. That's what I did here. So I'm starting with, trying to find x, I'm starting with a, and I'm multiplying by root 3 on both sides. Well, this already has a root 3, right? Because that was the a value. So I have to multiply it by root 3 again. Doesn't matter what it is, it's what you do to it. So this becomes 115 root 9, which is 115 times 3. I don't know what that is off the top of my head. 345, I think. 115 times 3. So this is 345. 345. Okay, number 18 asks what the area of this triangle is, equilateral triangle with a base of 4. So I just sketch out a picture. Equilateral triangles have 60-degree angles all the way around, but we're going to drop this perpendicular line, which is going to be our height, which splits the base into 2 equal parts. These sides are still 4. So I have, remember this shaded is at 30, 60, 90. So the height of this triangle, right, is whatever the base is times root 3. So it's 2 root 3. So area of a triangle, 1/2, base times height. Substitute 1/2. Your base, your entire base is 4. Your height is 2 root 3. And you can think of it like commutative property for multiplication. 1/2 times 4 times 2. Just kick that root 3 to the end. Half of 4 is 2 times 2 times root 3, 4 root 3. All right, now 22 is a bit more challenging. It's just a right triangle that involves a quadratic. I'll explain how that works. So in a right triangle, you should be aware of Pythagorean theorem. We know that a squared plus b squared equals c squared. So we call this a, call this b, and c. C has to be the hypotenuse. A and b can interchange. So this is the same as a, b, and c. So this is a squared plus b squared, and it equals c squared, and I just popped the expressions in there. Variable expression, binomial expression, and then a numerical expression, 13. So x squared stays x squared. This, remember, you have to FOIL it. So 2x plus 2 squared ends up being this amount, 4x squared plus 8x plus 4. And then 13 squared is 169. Combine your like terms, 5x squared, 8x stays where it's at, 4 stays there. We move 169 over to set the equation equal to 0, so we can solve for x using the quadratic formula. So that changes that to negative 165. We get our a, b, and c values. Remember quadratic formula. X equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Substitute your a, b, and c values in, plug and chug, right? Get down here. Remember, this negative 4 and this negative 165 are multiplied to make it a positive number. Positive 3364. Okay, that ends up being root 58. And then 10 is in the denominator. 2 times 5 is 10. 10 goes, so 2 goes into all of these numbers. That's your greatest common factor. So divide everything by 2, and that's how this 4 is there. 58 divided by 2 is 29. 10 divided by 2 is 5. So now I'm going to take this top chunk, and I'm going to do negative 4 plus 29, which gives me 25. And then I'm going to do negative 4 minus 29, which gives me negative 3. And then both of those are divided by 5. So this ends up being 25 divided by 5 gives me 5. This gives me negative 33 divided by 5 is negative 33 over 5, or negative 6.6. Both of those are solutions. We're talking about geometry and side lengths of a triangle. Can't have a negative length. So we cross out the negative number, where it's said to be extraneous. Mathematically, it's there. Physically, it can't be there. That's number 22. Okay, probably the hardest problem.